Well, hello everyone. I hope you can hear me. We're going to go ahead and get started with the webinar for today. I want to thank you for joining me. What we're going to talk about today is the Dragonfly platform, the software that we make here at ORS, and how you can do easy quantitative analysis. I would ask that you keep all of your microphones muted during the presentation so that it will be less disruptive. And then at the end, I'll open it up for questions, and we can take questions, and you can unmute your microphones at that time. Well, thank you again for joining us. What we're going to be talking about is how to do quantitative analysis on 3D images. I think what you'll see today are that there are features and strengths of the application that you can do in Dragonfly that you might do in other applications, but the workflow is going to be so much easier in Dragonfly that you'll find that you become more productive. So let's go ahead and get started. My name is Mike. I've been working in 3D visualization and image processing for almost 15 years, or a little more than 15 years actually. And so my background is in TEM microscopy, but I've been working in applications areas with scientists on micro-CT and FibSim for almost a decade. So I have a pretty good idea of a lot of the workflows that people need to deal with and data types they need to deal with. So I'm happy to address questions on your particular applications at the end of the presentation. So ORS is a company called Object Research Systems. We're headquartered in Montreal. We've been in business for almost 13 years now. We started out by making a product called ORS Visual, which is used in diagnostic radiology. So it's used in clinical applications in hospitals. And recently we pivoted to start trying to focus on dealing with the microscopy market and scientific imaging and research imaging. And that's the product we'll be talking about today called Dragonfly. So Dragonfly is an application that's used for 3D data visualization and image processing and analysis. So it allows you to import data of different types and different sizes and different scales. It allows you to do measurement and inspection. Most importantly, it allows you to do the image processing you need so that you can do image segmentation, so you can really quantify your system and do the quantitative analysis, which we'll talk about today. It also supports animation and export of high-quality screenshots for high-impact presentations. So this is the basis of what Dragonfly does, and it has many features in all of these areas to support users. So today we're going to talk about the quantitative analysis framework. A little more about Dragonfly. We're on a very rapid innovation pace. So Dragonfly 2.0 was launched in September. We have 2.1 coming out in April. That's available in beta next week. And the 2.1 introduces our macro engine, where users can record actions that they do in the user interface so they can play them back and apply them to other data sets. We also have a machine learning segmentation engine so that you can apply machine learning segmentation techniques to large data sets that are too difficult or too labor intensive to segment by hand. This fall we'll be launching 2.2, which will have our first beta releases for Mac and Linux. And then we'll have our first production releases on Mac and Linux coming after that. We're built on some core technologies that are quite useful and quite advanced. All of our platform now is built on Anaconda Python 3.5, which gives users access to all of the scientific computing libraries that are bundled with Anaconda Python. You'll see we have a high-impact volume rendering engine, which can give you very impressive graphics. And you'll see that we use a number of different segmentation tools that make it easy for users to get more advanced segmentations. Because we're built on Python, we have put into our framework the ability for users to extend the software, and there are a number of sockets where they can write plugins, where they can use the online console, or they can write their own object analysis measurements, or write their own image filters, or write their own full-featured plugins. Coming this spring, we'll be launching an app store where users can write their own plugins, and then those plugins can be shared and distributed with the greater community through the App Store. You'll see that we have licensing options, various licensing options for different commercial institutions, but we also offer free licensing for non-commercial use in most countries. If you have questions on that, we can take those questions at the end. So with that, I'll go ahead and switch over to Dragonfly and start some of the live demonstration. We're going to talk mostly today, and we're going to keep this to about 35 minutes, I think. We're going to talk mostly today about quantitative analysis, but first I want to show you the software and just give you an idea of the framework of the software, of how it behaves. and how you get some simple things done. What we're looking at right now is a walnut data set that was scanned at the European Institute of Molecular Biology. Let's see if it was written in here. Yes, here at the European Institute of Molecular Imaging. So that data set is shared online through the resource Volreen if you want to have a look at that data set later. So what we're looking at here is the Dragonfly user interface. You'll see that you have panels in the middle for your viewer, and then on the left and on the top you'll have control panels where you can control what's seen inside the scene and the ability to interact with your scene. Over on the right you have a list of all of the results or all of the data that you're working with. So this is a list of all of the data sets I've loaded. So for example, there's one here called Walnut, but it's also a list of any segmentations I may have started. So there's tray, any rulers or annotations, so you see these rulers listed here. Anytime you click on any one of these objects in the list, you see its attributes below. So you see here this walnut is 400 by 300 by 300 pixels, and you can see the color maps that are used for rendering on screen. If you were to click on a ruler, for example, it would be highlighted in the view, but you would also be able to change its thickness or ask for a profile intensity of that particular ruler. The idea here is that anything you select from this list, you can see its attributes below. In addition to seeing these control panels on the top and left, you'll also see at the very bottom a status bar that tells you the current state of the application. Right now, I'm in the ruler state, which means if I drag with the mouse, I'll create a new ruler object in my list. The states are defined by these gray buttons, so the application can only be in one state at a time. If I come over here to this manipulate panel, I can mouse over this and it gives me a tooltip that says, oh, this is the pan state. So if I were in that state, then I could pan around. If I were in the zoom state, I could zoom. If I were in the track state, then I can manipulate the 3D window. It turns out it's very easy to have shortcuts to go to different states, so I can have a shortcut that puts me in the zoom state or in the pan state. So it's very easy to change states without even having to push the buttons directly. The reason we have these gray buttons for states is to differentiate them from the blue buttons, which are action buttons that don't change the state. So if I'm in this window and I want to change the view, I could rotate it 90 degrees or rotate it back or flip it vertically. Anytime I do these actions, they don't change the state. I stay in that track state. Okay, so you have a little idea of how we're in different states and how you have the control panels on the top and left, and you have your data in your workspace over on the right. Now, whenever you load a data set, usually what you want to do is adjust the brightness and contrast or the window level. So let's look briefly at that. Anytime I have multiple views in my layout, I can always double click on one of those views and make it go full screen. So since I wanted to talk about brightness and contrast, I'll draw your attention to the window leveling widget, which you see up here. The window leveling widget allows you to adjust how colors are mapped onto the image intensity data. So you can see here that I have an image intensity histogram, and this lookup table defines it so that everything less than this intensity of 3300 is black, everything higher than this intensity of 11,300 is white, and everything in between on that interval is mapped on a grayscale. So I can manipulate how those colors are mapped onto the histogram directly. I can drag these bars. I can move the band itself. I can also use the window leveling state to drag and increase the brightness, or drag horizontally and do the contrast, or I can drag diagonally. Sometimes when you have a data set and it's hard to get started, you can use this state, the area state. If you're interested in the contrast of the meat of the walnut, I can drag an area here and now maximize the contrast in here. If you're interested in the shell, you could drag here. If you're interested in the noise structure in the air, you could drag here and now you could see some of that. Or you could drag over most of the image, and that's a good way to get an initial brightness and contrast setting. I'll go back to the track state. You also have what we call these text presenters on screen. The text presenter for window level allows me to drag like I'm in leveling state, where I can drag horizontally or diagonally. But you also see a text presenter for the field of view, so I can zoom in and out, and a text presenter for the slice, so I can change the slice number I'm looking at. Now if I double click, it goes back to a smaller view, and now I have all of these views again. I want to show you one more feature, but before I show you that, I want to mention that all of these control panels can be moved around where the user wants them. So this particular manipulate panel, if I want to, I can just drag it and position it somewhere else. I can double click and have it appear on another region in the user interface. Now, with the walnut, it's pretty easy to see that this is a cross section that goes right here through the walnut, and here's a cross section that comes down like this. But sometimes with more complicated data sets, it's useful to see these views in the 3D space. We're going to use our visual plane for seeing that. So if you look at this particular view, you can see there's a little red flag at the top. This view has a green flag, and this view has a blue flag. So with this red flag, I can use visual plane and find the red text that says top right view. And now when I click it, I see where that is in the user interface. Now what I can do here is I can turn off some of those features. So now you see that this view right here is a cross section right here. And it also cuts through this view, so I could actually grab here if I want to change the position of that. So anytime I want to see something, I can move all my views there. And anytime I want to change a particular slice, I can just drag it. So the other features of this are that I can turn on clipping, as we saw before, and I can clip in either direction. I can also turn on show data, which means now I can see the data there. And it's showing exactly the same view you have here. So if I had reduced the brightness or changed the transparency, now we can see this cross-section superimposed. For that matter, if I click on Walnut, I could change the lookup table for the 2D view just by dragging here. So if I wanted a more colorful view that emphasized the brightness and contrast, I could have this. What we've seen so far, all of these views are orthogonal, but they can very easily be oblique. It's very easy for me to grab this and now change the angle of the view. I can make a double oblique view just by grabbing it in the other axis. And in the 3D viewer, I can grab the tip to change the angle or grab the shaft to change the slice position. So basically, the visual plane module allows you to manipulate in 3D and see in 3D exactly where your cross-sectional views appear in 2D. Okay, I think that's enough in the way of background for showing the general purpose. Now I want to talk very briefly about segmentation before I go into quantitative analysis. Segmentation allows you to label different regions of the image. Let me take this image, and so I have better contrast. Let me click in the 2D view and change the 2D view to grayscale. That's going to give us better contrast with the segmentation that we do. So I can go over to my segment tab over here, and I have a panel called ROI Tools. And I also have a panel at the top called ROI Painter. I'm going to use those right now. If I want to, I can create a new region of interest for labeling, and I can type it in here and change the color. I don't need it right now because I've got one over here called tray. Suppose I wanted to segment the tray. Well, I could use the ROI Painter tool, and with a circular paintbrush or a square paintbrush, I could come down here and paint. Now that would become very difficult to try and do in a useful way when you're just trying to paint like that. So I'll hit clear. What I'll do as an alternative is I'll set up an intensity range. And so if I define an intensity range on walnut, and let's do this. Let's turn on walnut and tray and show an intensity range that corresponds to the pixels of the tray. Now what I can do is I can take my paintbrush, and now I can paint, and it's only going to paint underneath the paintbrush and where the intensity range is matched. So this allows me to go much faster. For that matter, I can use a 3D paintbrush, and now I'm painting a sphere. If you look in the 3D view, you can see that that sphere cut right through and painted in multiple slices. So if I were trying to do this and do something quick, I could go all the way back down to slice 0 and then scroll through the data. Whoops, let's fit the data to screen, and we'll just increase the brightness. And for this to be useful if we are on an XY slice, so we'll just do this. So what we could do is go down to the very first XY slice and paint through like this. Now if I wanted to paint the entire tray, I could do this without too much effort. We could probably paint it in about 30 or 40 seconds. If you get too much, it's very easy to come back later and erase. So if I don't like that, I'm using the Shift key to erase while I'm using the Control key to add. So you see you can do something like this to do some segmentation. Now let me stop right there. I think that's far enough to demonstrate. What you have here is you have all of this labeled. If I come over here and look at the tray, I can select it and I can see some of its attributes over here, like I can see its total volume. If I'm interested in modulating a little bit, I could come over here and use my ROI tools. If I wanted to do a 3D dilation, I could dilate and now it grows in 3D. One of the things I want to show you is with tray selected, you can see that it has some 2D opacity settings. So if I adjust it in this particular 2D, then you can see it changes how bright or dark it shows the tray in the 2D. But if I select 3D, I also have 3D segmentation settings. So I can do the same thing in making it brighter or darker, but I could also turn it off altogether. I could turn down the intensity of the region of interest, and now I don't see those data at all. So this allows me to suppress them or mask them out. Or I could do the inverse and show the region of interest, but hide it and not show the data set. So this allows me to focus on what I've segmented or focus on what I haven't segmented. So you have these tools and you can make them variable opacity. So it's very easy to control what you're looking at. For that matter, if you had this data set and you truly wanted to mask it out, you could take all of these blue pixels. I'll increase the brightness here for a minute. You can take all of these blue pixels and tell them you just want to cut them from the walnut dataset altogether, and now they're overwritten with zeros. So now they're actually overwritten and they're gone altogether. So even without the tray rendered, those pixels have been deleted and are gone from the dataset. So that just shows you how you can use regions of interest to calculate, for example, volume, but you can also use them to modulate the rendering or even to mask data outside of the rendering. I want to show you one more thing here. If I were to create a new region of interest and I call this one cutaway, and let's give it a color white, for example. And I'll do the same thing I did before where I use a 3D spherical paintbrush, but I'll come over here and suppose we, and I can change the size of my paintbrush with the mouse wheel by going up and down. So suppose I've taken an area like this and I paint a little sphere there. Now, since we already saw that I can turn on 3D rendering, and with 3D rendering I can use it to adjust opacities, now we can see that I could turn down the highlight and turn down the ROI. And now I'm using it as a cutaway to look inside the data. So it's a nice way to do a spherical cutaway. One of the panels we haven't looked at yet is Scene View Properties, which allows me to adjust my light source. So you could set up a view you like, and now you have a cutaway inside your data set of interest. So I think that gives us enough of an introduction to a number of the tools in the user interface and how regions of interest work. What I'll do now is load another session which has a data set that we can use for talking about quantitative analysis. Okay, so what we're looking at now is a single data set, and I'll adjust the brightness and contrast, and I'll also adjust some of the rendering attributes so I have a little brighter and a little shinier contrast. What we're looking at is a 3D FibSim data set of a number of metallic grains. Now, suppose we wanted to segment these grains and quantitatively describe them. What is the volume or what is the aspect ratio of the grains? What I will do is I will come over here on the Define Range tool and I'll look at the histogram and I'll just say, I want everything that's here or brighter. And if you look over here on this window, you can see that it's highlighting those grains in red. I'm just going to tell it Add to New. And so now I have a new region of interest. I could double click over here and call it All Grains. I could change the color if I wanted to, etc. I'll just turn off the visibility here. What we're going to do is we're going to right click on my region of interest and go to Advanced Analysis so that we can go into our Objects Analysis panel. So there's a lot to see here. Let me walk you through what we're seeing here. I'm going to hide some of these panels, then we can look at them later. So what's happened is I've taken all of those grains that were blue, and now they have been subjected to a connected components analysis so that instead of all the pixels being either blue as grain or not blue as not grain, now each of the blue grains has been itemized and colored based on its separation from other grains. If we look at this, we can see that we have a table of 2,359 rows. So what it did when I clicked Advanced Analysis is it went through and itemized every grain, and it gave a volume calculation on every one of the grains. Here we have a color map that allows us to map how we're seeing them in this window. So I could switch to, for example, spectrum, and now if I choose on volume, now the smallest grains are purple and the largest grains are red. Now, just to make that more obvious, let's do it in 3D. So I'll turn on 3D here, and now we can see that again, the largest grains are red and the smallest grains are purple, and some of the grains in between are yellow and green and blue. So at this point, we've itemized all of these grains, and we have their volume. Now, from the table, I could select some of the larger grains. With them selected, you can see them appear with more opacity. The reason that's happening is here I have a slider that lets me adjust the opacity of all of the currently selected grains, so I could turn them down, or I can adjust the opacity of everything that's not selected. So I could say, let's see a few more grains as I select from the table. I can always clear the selection at any time. So that gives me a lot of control of interacting with this. Now, if I look, I may see that there are, in fact, a number of very small grains that maybe I want to exclude from the data set. Maybe they're just 1 or 2 pixels, and they're really confounding my interpretation. So I could scroll down and select a number of grains, and let's say everything from here smaller or from here smaller is an artifact that I don't want to include. Well, at this point, I can just click Delete from ROI, and now those 600 rows will not be considered, and now I'm down to just 1,700 rows. So now I have a smaller data set, so I've done a little bit of pruning. I'd like to do some more pruning and analysis, but first I'd like to compute some more measurements. What I'm going to do is click on More Attributes, and here is a list of a number of measurements that are available. So let's choose to have phi and theta and aspect ratio. If I have data sets like my FibSim data set, I could choose to get the mean intensity of every grain. If I had multiple channels of data, I could get the mean intensity across multiple channels. So I'll just hit apply, and now for all 1,700 grains, we have now not only the volume, but the phi and theta and aspect ratio and mean intensity. And so if I'm selecting everything in the table, I can select by volume or by phi or by theta or aspect ratio, and the rendering is updated inside the 3D view. Now, those more attributes, I just want to say a moment about that. There's a folder on disk. So there is actually something called the Python plugins folder, and we go to Objects Analysis and Python script generators. There's code here that allows you to write your own measurements. So if you look here, there's a class called Statistics Generator Abstract. If you want to create, in addition to volume and surface area, maybe you want to measure Faraday length or sphericity or some sort of shape factor, you can extend the Statistics Generator class and write your own Python code for making measurements. So here's our Statistics Generator's basic class, which is the code that defines how volume and surface area and center of mass, etc., are calculated. So it's very simple. A user can just drop their own calculators inside this folder, and now they have their own custom calculations. We'll be launching an app store this spring, which means after you write your own custom calculations, if they're useful and you want to share them with the greater community, you could just upload them to the app store and distribute and share your plugins that way. There are a number of different ways you can do customization of Dragonfly, but today we're just talking about objects analysis. So that's just one way you can extend the functionality of objects analysis. Now at this point, we've removed some of the rows of smaller ones, but let's look a little closer at volume. I've been in the table view all of this time, but if we switch to histogram, I can choose a one-dimensional histogram of any of these data sets. Now at this point, maybe I'm interested in trying to do some subgroup analysis. So let me extend subgroup. Here on the histogram panel, I can, let's say I want to separate the large grains from the small grains. Now, I've drawn a filter, and everything inside this filter amounts to 7 grains. I could draw another filter for the smallest grains. Now, if I wanted to, I could label this one large, and I could label this one small, and then everything that doesn't fit in either the large grains or the small grains is left out, and that's defined as complement. Now, what I can do here, let's remove the filter altogether and just focus on the large grains. So if I think, well, maybe some of these shouldn't be counted as large grains, then I can just dynamically resize this. Now I'm down to just 5 grains. Now, I am going to name this large grains, and then suppose we want to do analysis on all the grains that are not large. Now, it's interesting, we've been focused on volume at this point, but if I switch over to aspect ratio, if I'm interested in partitioning based on aspect ratio, if we look here, we can see that one of these subgroups turns out to be mostly platelet-liked, and another subgroup tends to be mostly fiber-liked when we divide by aspect ratio. So I could rename these my platelets, and I could rename these my fibers. If you want to, you can go back to the table and remove individual ones or sort them out, but let's just continue with a quick analysis now. And of course, we can change the colors on these at any time, so I could have orange for my platelets and blue for my fibers. And what happens here is right now we're coloring everything by attribute. So if we look up here, everything is colored by attribute. Everything is colored by aspect ratio right now. I could go back to volume, and now everything that's selected is colored by volume. But if instead I choose by subgroup, now when I choose this, I've got my platelets in red and my fibers in blue. If I go back to the top of the tree, then I've got all of my large grains in orange and everything that's not large in green. If I wanted to see the leaves of this tree structure, then now I've got all of my large grains in yellow, in orange, and the complement grains are now either red or blue, depending on whether they're platelet or fiber-like. We've looked at volume and we've looked at aspect ratio, but we can also look, let's look a little more closely at the fibers. Let's look not at one parameter, but 2 parameters. So if I click phi and then I control click theta, now I have a 2-dimensional scatter plot. What I'll do here is I'll define some subclasses based on orientation. So I'm just going to hit the plus button a few times, and now I've got 4 subgroups. So what I'm going to do is I'm going to say everything that doesn't go into a subgroup, let's just make it a dark gray. And let's say the top one is, let's just give some high contrast colors, yellow and pink, and maybe a bright green, and maybe a bright blue. Okay, that's good enough. So what I can do is I can say for the first group, fibers, let's choose an area here, and I'm using the mouse wheel to change. Let's choose this area on the 2D scatter plot to be fiber group 1, and let's go to fiber group 2, and we'll get these, and then we'll go to fiber group 3 and get some of these, and then we can go to fiber group 4, maybe get these. And what you have over here is you've divided you've done subgroup analysis not based on just volume and aspect ratio, but now the phi theta angle. So if I click on the fibers group 1, I can see all the fibers that are going in this direction, and fibers group 2 are fibers going off in this direction, etc. And again, if I click here, then I'm seeing them in all of the directions color-coded by subgroup. Now I could always go back at any time and color by volume. So if I'm interested in coloring by volume, I can choose these fibers and color them just by volume, and that's what we have. So you have the ability to look at any subgroup at any time. And recall that anything that's not selected, you can increase the opacity just by dragging that slider. So here we are looking at any of these fiber groups colored by volume. Okay. So that gives us most of what we wanted to look at today for the objects analysis. What I wanted to show you is that once you've done segmentation, and we could have a separate webinar on segmentation if you're interested. Once you've done a segmentation, you can do analysis of your data set by computing measurements and then doing subgroup analysis. Then you can use that for doing rendering or doing further measurements. Anything on the table, you can select either a small group. So here I'm just looking at the group of 5 fibers, or here I'm looking at all the small fibers. I can always take what's visible on the table and do a select all, and now I can export it to a spreadsheet if I want, or I could create a new region of interest inside my workspace in case I want to do further manipulation. I want to do dilations or erosions or intersections or unions of regions of interest. All that becomes possible by manipulating the table and then exporting new regions of interest. So I think that covers most of what I wanted to say for today. What I will do now is open it up to questions. So if you'd like to ask a question at this point, you can go ahead and unmute your microphone. And I think I had muted one person, so I'll just make sure he's not muted by me anymore. And I'm happy to take any questions you have right now about anything we've talked about or about anything in Dragonfly in general. So if you have any questions, go ahead and ask them. If we don't have any questions for the next minute or two, then we'll go ahead and wrap it up and close it down. If you don't have a microphone connected, you could also ask your questions through the chat window. So on the GoToMeeting panel, under Attendees, you find Audience View, and then under Audience View, you find Chat. You can type a question there, and then we'll be able to read that question. So Martin asks the question, are there any thoughts on uncertainty quantification at gray levels? So I guess it really depends on the application and the experimental setup. So you could have a number of segmented objects, and then you could compute the mean and standard deviation and look at the distribution of gray level inside the segmented objects. You could also be concerned about how the distribution of gray level may introduce uncertainty when you're doing the segmentation. So you may want to do some filtering, or you may want to do some analysis of the gray level. You can do histograms of different areas of the image to see if that is an issue. But I would love to talk about this more offline, and we could talk more about the application area and the imaging modality and how that might introduce uncertainties. But I don't have any specific answers at this point. Other questions? For any of you who have not already downloaded Dragonfly, anybody can start a 30-day free trial of Dragonfly. You can request at our website. Once you get a trial and install it, then you'll have a license that lasts for 30 days. We're happy to connect with you and do a demonstration or answer your questions by email or phone so that you can get up and using. We also have some online videos that show you how to use Dragonfly, and then there's the online help, which is a HTML navigation where you can search through the different help topics. Right now, we're still shipping Dragonfly 2.0, which we've been shipping since September. We've been doing alpha testing of our 2.1 release, and next week we start beta testing of that. And then in April, we'll be shipping the production release of 2.1, which adds some of the new features, such as the macro engine. We'll be sure to offer some videos to document some of the new features in 2.1, such as the macro engine for recording and playing back sequences of actions, but also the machine learning segmentation for training segmentations based on a little bit of human interaction that can then be extended to the rest of the image. So we'll be sure to offer those webinars. If you're interested, you can just send me an email and tell me you'd like to hear about those. If we don't have any other questions, then I'll go ahead and thank you all for your participation and attendance. If you would like a copy of the recording from today's webinar, just send me a note. I'll be able to send that out about 1 hour from now. Or if you have further questions, don't hesitate to send me a note. But again, thank you all for your time and participation, and let me know if you have any questions or discussion topics we can follow up on. So have a good evening, everybody.